Hi everyone, here is our next question from computer organization from the topic CPU design, and this question was asked in the year 2008 for 2 marks. The question is, consider a CPU where all the instructions require 7 clock cycles to complete execution. There are 140 instructions in the instruction set. It is found that 125 control signals are needed to be generated by the control unit. While designing the horizontal microprogrammed control unit, single address field format is used for branch control logic. What is the minimum size of control word and control address register? So here the control word or the micro instruction would contain two parts. One is micro operation part, and other is address part. Now, as it is a horizontal microprogrammed control unit, that means each bit in micro operation would be for one of the 125 control signals, right? So there are in total 125 control signal, so the width of micro operation field would be 125 bits wide. So micro operation would be 125 bits wide. Now this address field would be for addressing or getting the next micro instruction to be executed. So we need to find out the number of bits in this address field. So from there we can find out the total width of this micro instruction, right? So what would be the width of address field? And for that we need to find out the number of micro instructions to be stored in the control memory. So total number of micro instructions that would be required here would be equals to 140 into 7. Why? Because there are total 140 instruction, and each instruction has got 7 clock cycles, and for each clock cycle we need to generate separate set of control signals, right? So for each clock cycle we would need a specific micro instruction. So for total 140 instruction we would be requiring 140 into 7 micro instruction, that is equals to 980 micro instructions. So these many micro instructions are required, and these micro instructions would be stored in control memory, where there would be 980 micro instructions stored. Now to address each of this 980 micro instruction, the number of bits that is required to address one of the micro instruction would be equals to log base 2 980 ceiling. So that would be equals to 10. So from where we are getting this formula is that using 10 bits we can actually address 2 to the power 10 different micro instruction, and using just one lesser bit, that is 9, we can actually address only 2 to the power 9, that is 512 micro instructions. So 9 bits are not sufficient for addressing 980 micro instruction. We would be requiring minimum 10 bits to address one of the 980 micro instructions, right? So from there we have got this formula, log base 2 980. Log base 2 980 is 9 point something, and to that if we put a ceiling then we would get 10. So minimum 10 bits are required to address one of the 980 micro instructions. So this address field would be 10 bits wide, and this is what the width of the control address register, because control address register would contain address of the next micro instruction to be executed, right? So the width of control address register is 10 bits, and the size of the control word, that is the size of micro instruction, is addition of the width of micro operation field and address field, that is 125 plus 10, that is 135 bits. So the correct option is 135, that is width of control word, and 10 bits is the width of control address register. So 135, 10. This is the correct option. Thanks for watching. Bye.